Dear students, today I am going to start a module 5th, that is a forced vibration. Okay, so already we studied about the free vibration. So here the main difference between module 4 and module 5 is where we are going to consider without external force vibration, but in this problem, in this module, we are going to consider the with the help of some external forces, we are going to vibrate the problem, that is vibrate the component. Okay, so how much force going to transfer from one system to another system, and we need to calculate here the spring, damping and stiffness. Okay, all those things we are going to consider in the module 5, that is forced vibration. Okay, so free vibration is nothing but what the vibration takes place itself, that is called as free vibration, but whereas here forced vibration is that is the system will vibrate within some help of what external force, that is called as forced vibration. Okay, so here before starting the forced vibration and the free vibration, let me understand what you mean by vibration. Okay, so vibration is nothing but what it is a vibration is nothing but what it is a periodic back and forth motion of a particle or a body, okay, of an elastic body, okay, is called as vibration. That is the any component which will be displaced from one position to another position, that is a vibration takes place, that is called as a vibration. Okay, otherwise to and fro motion is called as vibration. Okay, so another definition if you say means from its any component from its mean equilibrium position, it will go to allow some changes. Okay, some vibration, that is some that is what some changes will be happen. Okay, that is called as this vibration. Okay, so to understand this, let me understand some notations. Okay, let omega is an frequency, okay, operating frequency. If suppose if you let us assume omega is equal to operating frequency and omega n is equal to natural frequency. Okay, so why we want to study this forced vibration? Because of what? To reduce the resonance. Okay, when this omega is equal to omega n, there is a chance of producing a resonance. Okay, if resonance occur means all mechanical component going to get what? Damage. Okay, such type of to reduce the resonance, we are going to study this forced vibration chapter. Okay, so how to reduce this resonance in a mechanical component? First one is to change the design. Okay, so how the beginning only in the beginning we have to change the design. Okay, so that we are going to eliminate or we are going to reduce the some amount of vibration, so that we are going to stop what? Resonance. Okay, second one is to change the speed. Okay, operating speed depending upon that component, we are going to apply the speed. Okay, third one is we are going to use some damping material. Okay, so if you use these three, we are going to reduce the vibration, that is the resonance. Okay, so again here we are going to get one force, that is called as an external force. Okay, so external periodic force, even if you apply some externally, that force is called as external periodic force. Okay, it is also called as an excitation force. Okay, again in this problem there are two different types of forces will be there: harmonic force and non-harmonic force. Okay, so harmonic force that is related to only the single degree of freedom system. Okay, for non-harmonic forces, that is multi degree freedom of system. Okay, for this non-harmonic force you are not having any syllabus, but only the harmonic force is what you are having syllabus. Okay, wherever I am going to use the external force, that is called as excitation force. Okay, you remember this excitation force nothing but what? Then external force. Okay, again there are two different types of excitation force, that is external force. One is a harmonic force and second one is what? Non-harmonic force. Okay, so harmonic force is nothing but what? So subject to a single force. Okay, that is if suppose if you are using sin and cos, okay, in the term of force, then that is called as a harmonic force. Okay, so how we are going to understand better vibration? Okay, look at this diagram. So in the left hand side, so this is a wheel tire. Okay, that is this is what the vehicle tire. Okay, so initially if you purchase new stage, the centroidal axis should be at exactly middle. Okay, so exactly middle. Okay, so after running some days, the centroidal axis can be shifted some displace, that is some distance. Okay, that distance, let us say x. Okay, the difference between the original axis and the displaced axis, it is called as an eccentricity. Okay, that is denoted by E. Okay, so how, why, on what basis the neutral axis is going to shifted means because after so many days running, the wear and tear of the tire takes place. Okay, because of that it can be shifted from one place to another place because of this unbalanced force created in the vehicle. Okay, so if it is happen means then there is a chance of producing a vibration. Okay, the vehicle move, while running the vehicle move what? The vibration, that is a zigzag motion the vehicle can move. Okay, that is called as the vibration produced inside the what? This wheel or tire. Okay, so why it is occur? Because the wear and tear of the takes place inside the wheel. Okay, so because of that the whole body can the whole vehicle can be vibrate. Okay, so that is called as a forced vibration. Okay, to reduce the resonance component, we are going to study this forced vibration. Okay, so here look at the diagram. So here the dotted line, that dot, okay, that is called as what? The mass removed, that is a wear and tear of the tire takes place. Okay, that is called as a mass is removed. Okay, it is rotated with an angular velocity, that is what? Omega. So external force, the vehicle force, that is what? F naught sin omega t. This is called as a harmonic force. Okay, and this one side is force is acting. Okay, so because to reduce such type of this, okay, we are going to study the force vibration. Okay, how much we are going to force apply to reduce the resonance and eliminate the vibration component. Okay, so this is about the brief introduction about vibration. And okay, so what do you mean by forced vibration and free vibration? Okay, forced vibration is nothing but what the vibration takes place with the help of some external force, that is called as a forced vibration. Okay, example, the best example is what, ringing a bell. Okay, if you are apply some external force on a ring bell, you are going to get some voice, how it will vibrate, that is called as what, forced vibration. Okay, so here the main difference between the free vibration and forced vibration is, free vibrations are produced when the body is what, is disturbed from its equilibrium position and released. Okay, itself only they will vibrate. Okay, that is called as a free vibration. Okay, forced vibration is nothing but what, here the vibration takes place with the help of some external periodic force. Okay, that is called as a forced vibration. Okay, so in the forced vibration, the frequency of free vibration depend on the body, and it is called as a natural frequency. Okay, natural frequency is very important to solve the problems. Okay, you have to remember the definition. Okay, so again I told you what is the forced vibration, what is the mean by forced vibration and resonance. Okay, to reduce the resonance we are going to study the forced vibration. Okay, so I wrote here some definition. Forced vibration occur when the object is forced to vibrate at a particular frequency by a periodic input force. That means if you take any body or any system or any component, if you apply some external force, that will displace at a some distance. Okay, otherwise it will fluctuate or it will vibrate, that is called as vibration. Okay, if an object is being forced to vibrate and its natural frequency generated, okay, and resonance will be occur, that is resonance will be occur when omega is equal to omega n. Okay, if that case happen, means we are going to get what the resonance. Okay, to reduce resonance we need to study this forced vibration. Okay, and along at the same time a large amplitude of vibration can be observed in that particular element. Okay, in the resonant frequency the natural frequency is become what, 0. Okay, so this is the difference between free vibration and forced vibration. Okay, so again I told you forced vibration is a type of vibration in which the force is repeatedly applied to the mechanical system. Okay, frequently we are going to apply, then the system vibrate takes place. Okay, frequently vibration occur in only in the case of forced vibration, not in the free vibration. Okay, so best example for the forced vibration is when the washing machine shakes due to the imbalance. Okay, so this is an best example for forced vibration. Okay, so again I wrote here the definitions of forced vibration. Okay, so forced vibration is when the time varying disturbance. Okay, that is they will change the load, displacement and velocity. All these three factors will be considered while applying the force. Okay, to the mechanical system, that is mechanical component. Okay, the disturbance can be periodic or steady state input. Okay, it will sometimes the vibration takes place very large, and sometimes they may slow vibration going to takes place. Okay, that is it will transfer from one position to another position. Okay, that is in a transient input or random input. Okay, the periodic input can be harmonic or non-harmonic disturbance. Okay, that is with the help of some, if you apply some initial force, that will be vibrate sometime 2-3 minutes. Okay, so for the best example for another best example for this forced vibration is here the washing machine shaking due to the imbalance, that is okay, this is the first example. And transportation vibration caused by an engine. Okay, in engine also you are going to get some vibration. Okay, or while the vehicle is moving on a road surface, that is uneven road surfaces, there is a chance of producing a vibration of the whole body. Okay, that is also a comes under this forced vibration. Okay, and also the earthquake. Okay, earthquake also comes under this example for this forced vibration. Okay, so next one is the second topic, that is the title is what, the transfer vibration and longitudinal vibration. Okay, for your syllabus only the transfer vibration and numerical problems will be there. Okay, what do you mean by transverse vibration and what do you mean by longitudinal vibration? Okay, so transfer vibration is nothing but what, the axis of the shaft which will be rotated perpendicular to the axis of the shaft. Okay, such type of vibration you are going to call as transverse vibration. Okay, so here on this transfer vibration you are having some numerical problem, that is a single load and several load or uniform distributed load. Okay, all these three problems you are having for your syllabus, we need to study those also. Okay, so here the definition I wrote here. So transverse vibration is nothing but what, it is a vibration in which the element moves to and fro in a direction perpendicular to the direction of the shaft, that is in advance of the wave, that is called as transfer vibration. Okay, so here you have to remember, in this case to and fro motion takes place, that is in the direction of what, perpendicular to the direction of the axis of the given shaft. Okay, if that happens, then that component you are going to call as transverse vibration. Okay, the main difference between the longitudinal and transfer vibration means, here in the transfer vibration the wave, that is the vibration in the direction which is which the wave shakes. Okay, if the wave shakes perpendicular to the moment of the direction, that is called as a transfer direction. If it is shakes in the moment direction, then the longitudinal direction, that then such type of vibration you are going to call as longitudinal vibration. That is, so around the movement of the direction, okay, in front of that axis shaft going to vibrate, such type of vibration you are going to call as longitudinal vibration. Okay, that is the difference between transverse vibration and longitudinal vibration. Okay, so next the another topic is what do you mean by critical speed? Okay, so critical speed is also very important here. Okay, so definition says what the critical speed is also, sometimes critical speed is also called as a rilling of shaft, okay, or it is also called as whipping of a shaft. Okay, so here the critical speed, okay, it is a speed in which the unwanted vibration happens when the vessel is rotating. Okay, so consider a shaft, okay, upon which a rotating mass going to fixed. Okay, so the crushing of the particle in a traditional mill is generally accomplished by rotating in the mill near to the critical speed. Okay, so here look at the diagram here. Okay, this is the shaft, okay, upon which one shaft will be connected. Okay, so here sometime they may connect here some rotated part, okay, rotating parts. Okay, when you switch on the any particular given shaft, that is a given component, this vibration going to it will rotate in a violently direction. Okay, the speed at which the shaft can be rotated in violently direction is called as what the critical speed. Okay, but as per any mechanical system, you are not going to operate at critical speed because it is very high speed. Okay, so it will hit to the your operating person. Okay, there is a chance of accident in between this shaft and this what the person. Okay, so this critical speed is very important. The running is a mixture in excess of the critical speed can be used desired mechanical vibration. Okay, so look at this diagram. So this is a particular shaft. Okay, so when if you start this operating this, when if you start this, okay, when if you start the this what the critical speed is this, when if you start switch on this any motor, that is switch on the you switch on this switches, means this shaft going to rotate very transfer direction. Okay, like this, look at the diagram B. Okay, there is a chance of shifting the CG. Okay, so initially this place, that is a centered axis, after rotating this CG will be shifted to some distance. Okay, that is the, it will bend. Okay, so that is called as a critical speed. It will be rotated around the clockwise direction or anti-clockwise direction. Okay, so the force which will be shifted from here to here, that is called as a centrifugal force. Okay, here I shown in the diagram centrifugal force. Okay, this is a critical speed which will be rotated with an angular velocity. This should be shifted. Okay, the definition says what critical speed is nothing but what the speed at which the shaft rotated in a violently direction is called as critical speed, and it is also called as a whipping of speed or rilling of speed. Okay, so look at the diagram here. The how much it displays, that is from this position to this position, that is called as a centrifugal force. Okay, so this is the axis of the rotation. Okay, so just to remember that critical speed nothing but what the speed at which the shaft will be rotated in violently direction with respect to the shaft, that is called as a critical speed. Okay, the shaft, the how much it is forcing the here the force will be acted outwardly direction. Okay, so that is called as a centrifugal force. Okay, this is the stationary, this is the rotation. Okay, this is the initial stage and this is a after rotation. Okay, so next and also in the critical speed you are having again there are two categories. One is the shaft without damping and with damping. Okay, so without damping a maximum amplitude will be present, with damping there is a less amount of amplitude will be present. Okay, that we need to study in the later, that is you have derivation and problems on this. Okay, this is about the critical speed. Okay, so next if you want to solve some numericals, so we have some equations. Okay, that is related to this force damped vibration. Okay, so consider this is a spring mass damper system. Okay, so one end is fixed, another end is external force is applying. So this is spring, sometime we are denoted as a K and sometime we are denoted as S. Okay, this is a damping C and this is a mass. Okay, so here we are going to apply some external force which is equal to what F naught sin omega t. Okay, so this is F naught, if you are using sin and cos term, that is called as a harmonic force. That is a harmonic force equation, that is external exerting force. Okay, so look at here. Here on this mass there are three forces are acting. So one is what given force, that is a harmonic force F is equal to F naught sin omega t. This is a external force, it is also called as a harmonic force. Okay, so here because of these two, because of mass, inertia force will be there. That is what inertia force is equal to mx double dot, which will be acted what upward direction. Okay, so next one is a damping force. Okay, so here look at the diagram. Because of this damping, so one force will be acting upward direction. Okay, that is damping force is equal to C of x dot. Okay, and one more here spring is there. Spring force is also acting what top, that is upward direction. Okay, so these four forces are acting on this particular element or mass. Okay, so mx double dot cx dot cx. Okay, sometimes we are going to use this, normally spring is denoted by k, but I used here s. Okay, so kx is also same to sx. Okay, any symbol you can use, but k is standard notation for spring. Okay, so according to the equation of motion, that is what the according to the Newton's second law, that is what for inertia forces is equal to external force. Okay, that you have to apply. So here external force is equal to F f naught sin omega t, how many forces are acting? 3 forces, 1 2 3. So inertia forces plus, that is mx double dot plus cx dot plus sx, which is equal to f naught sin omega t. Okay, so the equation can be solved with the help of what? The complete solution. This can be obtained with the help of some complementary function plus particular function. Okay, so you have to calculate this complementary function equation and particular integral equation, substitute, you are going to get the complete solution. But just for this slide, just to remember that if a given in a spring mass damper system means there are 4 forces are acting. One is external force, kx, cx, inertia force. Okay, you have to remember this. Okay, after solving we have derivations also. Okay, after solving, okay, you are going to get the complementary function, that is x, capital X e minus zeta omega n t sin of omega t t plus phi 1. This phi is equal to phase angle, and this is the damped natural frequency. This is what time period. Okay, zeta is equal to damping, omega is equal to natural frequency, x is equal to maximum displacement. Okay, particular function is equal to what? F naught whole divided by square root of s minus m omega square whole square plus c omega whole square sin of omega t minus phi. Again phi is equal to what? Here the phase angle. Okay, so these two equations you have to remember and substitute in the first equation. So you are going to get the general solution for the force vibration is x is equal to x of e. Just to substitute all this to, otherwise you summed these two. Okay, x is equal to x of e minus zeta omega n t sin of omega dt plus phi 1 plus f naught whole divided by square root of s minus m omega square whole square plus c omega whole square sin of omega t minus phi. So this is the general solution for force vibration. Okay, so this is very important while solving the problem. Okay, you have to remember this equation. Okay, so in actual practice the value of the complementary function is so small as you can neglect this. Okay, so amplitude is equal to what? Therefore the amplitude is equal to write as it is. Okay, f naught is equal to f naught nothing but what? This is a external force, that is a external harmonic force, that is excitation force. Okay, f naught is equal to square root of s minus m omega square whole square plus c omega whole square. So these are some equation, but you have to remember this. But in the later class we have to derive these equations step by step. Okay, so this is about the brief introduction about the force vibration. Okay, so in this slide you are going to understand what you mean by free vibration, what you mean by force vibration, and what you mean by critical speed, and what you mean by transfer vibration. Okay, these 4 definitions are very important to study this. Okay, so again here in this chapter you need to study the rotating unbalance. Okay, and the support motion between the vehicle and the road surfaces. Okay, critical speed, the transfer vibration, and having different load acting particular shaft. Okay, that is the syllabus for this, and the some numerical problems on this. Okay, so this is, if you want to solve the problems on forced vibration, you need to study what? You have to remember the list of formulae. So here we are going to get around maximum 30 to 35 formulas. You have to remember all those formula, and the main thing is you have to remember the notations. Okay, these notations are very very important. Omega is called as an operating frequency, omega is n is called as a natural frequency. Okay, when omega is equal to omega t, hence the resonance will occur. Okay na, so like this you have to study. Okay, I hope you understand this what is introduction to forced vibration. Okay, so next class we will go another topic. Okay, different, that is problems on this what the forced vibration. Okay, so thank you very much.